Hello everybody. In today's lecture, let us discuss about coma. So, a lens free from spherical aberration produces point image for point object. Okay, point image for point object situated on principal axis. Now let us think that the object is not on the principal axis. It is slightly far off the principal axis. The object is not on the principal axis. It is slightly far from the principal axis. Then how the image will be? When the object is slightly far off the axis, the image of a point object formed by the lens is found to have egg-like shape. The image is found to have egg-like shape or comet shape. Egg-like shape or comet shape. So, by seeing its shape, it is known as coma. So, it is having comet-like shape. So, it is called as coma. So, if object is slightly off the axis, slightly off from axis, it is not on the axis, just slightly off the axis, the image will be like egg-like shape or comet shape. So, only it is known as coma. Now, let this be the screen. Okay. Now, let us consider the object A slightly off the axis. Let us divide the lens into different zones 1, 1, 2, 2, 3, 3 in such a way. Now, the rays passing through zone 1 will focus at, let us think some I1 position on the screen. The rays passing through zone 2 will focus at some point I2. The rays passing through zone 3 will focus at some point I3. Right? So, we divided the lens into different zones. And rays passing through zone 1 focused at I1 point, from zone 2 I2 point, and from zone 3 I3 point. Right? Now, from this explanation and diagram, we are understanding that image is not in a perfect focus. So, this defect we call it as coma. The image is not in a perfect focus. This we call it as coma. Then why this coma arises? Why this coma arises? The first reason is, two reasons are there. The first reason is different zones of lens produce different lateral magnification. The lateral magnification of different zones are different. So, already in my last lectures we defined magnification. Okay. So, here the different zones will have different magnification values. Due to that only, if we see these different zones 1, 2, 3, we saw that the rays passing through zone 1 at I1, 2 at I2, 3 at I3 are focused at I3. As they are having different magnification, lateral magnification only, they focused at different points on the screen. So, image is not perfect or sharp at one particular point. Okay, this is one reason. And the second reason is that each zone forms the image of a point in form of a circle. Each zone form image in form of a circle. Okay. So now here, as from this figure, we considered that the lens is divided into zones, right? Now let us consider one zone, any one zone. Okay. So let this zone, now I am considering one zone, right? One zone. I am considering the one zone. So these zones are having some pair of diametrically opposite points. Diametrically opposite points, pair AA, BB. Next D, D, CC, in such a way. Okay, I considered one zone, and this zone are having a pair of diametrically opposite points. Now the rays passing from AA diametrical point focus at A dash. The rays passing through diametrical points B dash focus at a point B dash. The rays passing through diametrically opposite points CC will focus at C dash. Similarly, the rays passing through diametrically opposite points DD will focus at D dash. And these all points lie on a circular path. These all points A dash, B dash, C dash, D dash. A dash means rays coming from AA. B dash means rays coming from BB. C dash means that point where the rays coming from CC diametrically opposite points are concentrated. Similarly, D dash. These all A dash, B dash, C dash, D dash lie on a circle, a small circular path. So this circle we call it as chromatic circle. This circle we call it as chromatic circle. So as zone increases, okay, as the number of zone or radius of zone increases, radius of chromatic circle also increases. Now let us see. In starting, it will be like point size. Now for second zone, the radius of circle has increased. For third zone, it has increased more. For next zone, it has increased more. Right? So for I1 it is point size, I2 the circle radius has increased, I3, I4 in such a way. Now this is the resultant image due to different zones. The resultant image due to different zones. Right? Now it is in form of a comet. So only we call it as coma. Here image is not in a perfect focus when object is slightly far off the axis. That we call it as coma. Then how to eliminate the coma? How to eliminate the coma? First one, as usual, we will use stops. So stops will allow only the rays passing through the central zones and stop the rays going from the outer zones. So in such a way we can minimize this coma. it just permits the rays passing through central zones and stops the rays passing through outer zones. And second one, so coma may be minimized by designing the lenses of suitable shapes and materials. Designing the lenses of suitable shapes and materials. For examples, lens with refractive index 1.5, R1 by R2 minus 1 by 9 can make the lens free from coma, right? Or can minimize or eliminate the coma. And next, if the lens satisfies Abbe sign condition, that lens are also free from coma. So what is Abbe sign condition? Mu1 y1 sin theta 1 is equal to mu2 y2 sin theta 2. Okay, theta 1, theta 2 are the angles which the conjugate rays make with the axis. Mu1, mu2 refractive indices of the object and image spaces. Y1, y2 are lengths of object and image of zone. Okay, so theta 1, theta 2 angles made by conjugate rays with axis. Mu1, mu2 refractive indices of object and image spaces. Y1, y2 length of object and image formed. If mu1 equal to mu2, then the condition becomes y1 sin theta 1 is equal to y2 sin theta 2, or y2 by y1 is equal to sin theta 1 by sin theta 2. If this condition is satisfied by the lens, then it will be free from coma. Okay, in such cases, here y2 by y1, image length by object length, gives lateral magnification. Lateral magnification gives lateral magnification. If lateral magnification is the same for all the rays, irrespective of angles, then coma may be eliminated. If a lateral magnification is same for all rays of light passing through the lens, then we can eliminate the coma. Okay, so a lens satisfying the condition. Now we said this is constant, no? If this is constant only, that is lateral magnification is constant only for all rays of the light passing through the lens, coma may be eliminated, we said. So this is constant means we can write sin theta 1 by sin theta 2 is equal to constant. And this condition is nothing but the condition of aplanatic surface or lens. Aplanatic surface or lens. Thank you for watching my video. If you like it, share it and subscribe it. Thank you.